Hey everyone, today we're going to be taking a dive into two more derivative rules. These rules are very important to the foundation of calculating more complicated derivatives as we progress more and more throughout the course. These derivative rules do just need to be second nature as you calculate derivatives. And we'll continue adding to these rules as we progress over the next couple weeks. So we're going to start off with a little experiment, and this will lead to our first rule called the product rule. So the product rule is used in a situation where we are multiplying two functions and we want to find the derivative. So in this case, we are asked to find the derivative of h of x, and it is x squared times 3x to the fourth. This is a very basic example. Should be very easy functions to calculate. So I want you to take a second and do your best to calculate whatever you think the derivative of this function is. All right. So what you came up with the derivative is probably one of two options. Option one that you might have done to calculate the derivative of h of x, so h prime of x, you might have just done the derivative of the first function, x squared, that is 2x, times the derivative of the second one, which would be 12x to the third, using the power rules. And then maybe you multiply these together, gave you 24x to the fourth. So there's a possible answer. May or may not be correct. We'll see. The second option, maybe what you did is you multiplied them first. So when you calculated this derivative, maybe you went ahead and just rewrote h of x first, wrote this as 3x to the sixth. So you multiplied them and then took the derivative. So h prime of x then was 18x to the fifth. So that's another possible answer. But you can definitely see these are not the same answer. So only one of these is correct. The question is, which one is correct? The correct answer is option 2 here. H prime of x is 18x to the fifth. All right, and there is a way that we can prove this using the rule, the first rule which we're going to talk about today. But just to highlight one thing, in this first option, if you did it this way, essentially what you did is if we called this first function, if we called this f and we called this one g, you essentially did f prime times g prime, right? You took the derivative of them separately and just multiplied them. However, you can't exactly do that with derivatives. You can if they were addition. If this was x squared plus 3x to the fourth, you could then calculate them separately, right? And that would give you a valid answer. However, it does not work for multiplication. So this is not a valid way of finding a derivative. The only problem with this is if we had a function, let's say said h of x was x squared times the cosine of x, which is something that we will learn in the next few days. You can't combine these two functions, right? You can't combine x squared and the cosine of x. This is as simple as it gets. So we can't do like we did in the option 2 where we just combine them together and then found the derivative. So we need something else in order to find this derivative. And that's where the product rule comes in. So the product rule is used to find the derivative of the product of two, or it could be more, functions. This rule, which you do need to memorize, don't think of it as memorizing the formula necessarily, but just memorizing this process. So to define the derivative of a function, we're going to call f of x times g of x. Or you could write this as just f times g if you wanted to. But if we're asked to find the derivative of the product of two functions here, f of x times g of x, the derivative of this is going to be f prime of x times g of x plus, plus f of x times g prime of x. So that is how we compute the derivative. We do the derivative of the first function times the original second function plus the original first function times the derivative of the second function. So in other words, if I were to just write that out, the derivative of the first function times the second plus the first function times the derivative of the second. Sometimes you'll see it switched around. Some people will prefer to write it as f prime times g plus g prime times f. You can write it however way you want, as long as you keep it in. And actually, it doesn't even matter the order on this one since it's addition. Oops, sorry guys. So no matter how you want to write it, generally it's written this way: f prime times g plus f g prime. But again, some people will prefer to switch these last two and write it as g prime times f. Sometimes I like to do that just to do the derivatives first. You do the derivative of the first one times the second, plus the derivative of the second one times the original first function. Either way you do it is perfectly fine. Just stick with one method of doing it. All right, so let's put this into practice. Let's go back to the little experiment. And if this rule is true, let's call this option 3 using our product rule. We should end up with this same answer, 18x to the 5th. All right, so using option 3, h prime of x would be the derivative of the first function. So this would simply be, sorry guys, having some issues today. This, oh, it keeps doing that. This would be f and this would be g. So it's going to be f prime, that's 2x, times the original g, so times 3x to the 4th, plus the original first one, x squared, times the derivative of the second, 12x to the 3rd. So I've done f prime times g plus f g prime. And then if I were to simplify this, I should end up with 18x to the 5th. Let's see. 2 times 3 is 6. First and the 4th makes us 5th power. Plus 12x to the 2 and 3 is 5th power. We then can combine like terms. We do get 18x to the 5th. So we do get the same answer. In this scenario, it obviously would have been easier to multiply first and then find the derivative. It would save you some time. But again, we're going to see a lot of scenarios where that's not necessarily the case. So in all of your homework problems on this, I do want you to use the product rule. So let's try a couple more example problems. Throw in some a little bit more challenging ones here. So theoretically, you could actually multiply this one through. You could distribute first, and then you could differentiate. But that's not what I want you to do. I do want you to use the product rule on this. All right, and you might also want to just rewrite this first. This is going to be the 2/3 power, right? You just keep the rest of it. You need to be very comfortable with rewriting those. Remember, the top is the power and the bottom is the root. So then if we're asked to find y prime, we look at this as f here, and look at this as g. So we do the derivative of f, which is going to be 2/3 x to the negative 1/3. Okay, so that's the derivative of our first, times our original second, 2x minus x squared, plus the original first, so x to the 2/3, times the derivative of the second. So derivative of 2x is just 2, minus x squared would be 2x. So this is our answer. Now, obviously, you would want to simplify this. You'd want to distribute, combine like terms, all that good stuff. However, for just this video and this assignment, I want you to just leave it here. This would not be how you'd want to turn it in on the AP test, obviously, but I want you to leave it here because this is simply a practice over using the product rule. And if you could just at least leave it at this point, then I can tell if you did the rule correctly. So this is applying the product rule. Again, in most scenarios, you would want to go ahead and distribute each of these, combine like terms from there. But this is simply just to practice on the product rule. So it's fine to just leave it here for this video, for this assignment. I want to see that you know what you're doing. Right? Let's go ahead and try another one. So this, again, is a function that we could actually FOIL this out if we wanted to and then find the derivative. But again, this is a practice on the product rule. So do not FOIL this. Again, we refer to this one as f, and the second one we could refer to as g. So the derivative of this, we'll write f prime of x, would be the derivative of the first function, f prime. So that's going to be 18x squared minus 1. And since we have two terms, we do want to write this in parentheses, times the original second, 10 minus 20x, plus our original first, 6x cubed minus x, times the derivative of the second, which is just going to be the 10 goes away, minus 20x just becomes minus 20. So again, leave this as your final answer for now. You obviously could simplify this, leave it here for now. Okay, so it's just f prime times g plus fg prime. All right, that is our first rule, the product rule. The next rule is kind of similar. It is called the quotient rule. So if product was representative of multiplication, quotient, as you can probably imagine, is for division. So we use this to find the derivative of the quotient of two or more functions, generally just two functions. So the rule that we're going to use for this, if we're asked to find the derivative, d over dx, of some f of x divided by g of x, just a little bit more complicated here. We're going to do f prime of x times g of x minus, notice the sign change there, f of x times g of x, times g prime of x. So this is almost exactly the same as the product rule so far, except we just switched it to a minus sign. Okay, and then we're going to write this over g of x squared. So f prime times g minus fg prime over g squared, the original g squared. So you can see definitely a little bit more complicated. However, it's almost exactly the same as the product rule on the numerator, except we just change it to a minus sign, and then we're dividing it by g squared. So again, something you need to memorize, know how to use, memorize. And if you want to sort of memorize the short form, it's just f prime g minus fg prime over g squared. A little easier to memorize. Same with the last one on the product rule. If you want to memorize this, it would just be f prime g plus fg prime. That's it. All right, so you need to memorize both of those. The memorizing should just sort of get stuck in your head as you do problems. So in the same way as we did the last ones, we're just going to do this, not simplify it at this point, but just go ahead and solve these problems. So our first one here, this is some function w of z, and we're going to find the derivative. So view this top function as f, view this bottom function as g. So w prime of z is going to be the derivative of the top, okay, f prime. Well, let's just write out f prime times g minus fg prime over g squared. So the derivative of the top, which is just 3, times g, so the whole bottom, 2 minus z, minus the original top there, 3z plus 9, times the derivative of the bottom, which is just negative 1. And all of this over the original bottom, 2 minus z squared. We'll leave it right here for now. I know you guys are good at simplifying, but at this point, just leave it here so I can see your work. Okay, so we got f prime times g minus fg prime over g squared. Let's look at a couple more. All right, so we've got h of x, and we've got two functions again. So h prime of x is going to be, I'm going to write it out, f prime g minus fg prime over g squared. Derivative of the top, you might want to actually just write this as 4x to the 1/2 power, first of all. So we multiply the exponent, it becomes 4 times a half, which is 2. So 2x to the negative a half times our original bottom, x squared minus 2, minus original top, 4x to the 1 half, times the derivative of the bottom, which is just 2x, all over the original bottom squared, x squared minus 2 quantity squared. Again, leave it just like that. All right, and one more, cap it off. We have the function 4 over x squared. Now, obviously, at the outset of this, you could just rewrite this as 4x to the negative 6 and evaluate it that way. Don't do that. I want you to do it using the quotient rule. This is f, whoops, top is f, bottom is g, f prime g minus fg prime over g squared. It's helpful to write out every time. It helps to get stuck in your brain as well. So our derivative here, f prime of x, derivative of the top. Now the derivative of 4 is actually just 0. So I am going to write 0. Don't just write nothing, because if you write nothing, then when you write g, you're going to think it's just g. But it's not. It is 0. So it's important that you write 0. 0 times x squared minus 4 times 6x to the 5th over x to the 6th quantity squared. And you can leave it here for this. But if you were to simplify this, that first term would actually just go away. It would just be 0 minus 24x to the 5th over x to the 12th. And then so you would reduce it from there. But again, it's important that you put that 0 because that will make that x squared go away. All right, so that is a brief introduction of those two rules. I'm going to have an assignment that practices both of these. Take your time. Again, you do not have to simplify these problems. Just leave them as is. And as always, reach out to me if you need some additional help. Yeah.